In this video, we'll talk about debugging. Programming can be a lot more fun if we have some tools to figure out why the program isn't behaving the way it's supposed to. Bugs are problems with our program, and debugging is the process of getting rid of those problems. I have a program here that has some problems. What this program intends to do is evaluate some simple math functions. It takes the variable I from 10 to -1. Remember, we don't actually get to -1, so it'll take it from 10 to 0. And within this loop, evaluates I to the second power using math.pow, and then again evaluates I to the second power using a recursive power function that we made, and then evaluates I factorial using another recursive function to evaluate the factorial. When I run this program, I see that I've got some errors right away. It says maximum recursion depth exceeded in comparison. If we want to pinpoint where the error is, we just look at the last line here. It says it's in line 5, and if we click on the link, it'll take us to the offending line. Now, one of the old-fashioned ways of debugging is to add a print statement that might send a message and maybe the status of one of the variables. But a lot of times that's not very helpful. We see we just got the same error and a whole bunch of highs. So I'm going to delete the print statement. And instead, we're going to use PyCharm's debugging tool. The first thing we need to do is insert a breakpoint, and you do that by coming over to this blank space right next to the line numbers and clicking, left-clicking, and you'll see a red circle show up, and that's called a breakpoint. We'll see how that works. We come up to Run. Instead of clicking Run, this time I'm going to click Debug. The code starts and then stops as soon as we get to the breakpoint. We can see a couple windows show up. There's a frames window that shows us our execution stack. We can see all the variables that are in scope, and a watch list over here that we'll use later. What I'm going to do is step through the code one line at a time, and I'm going to use this button that says Step into my code. Step into my code will step through all the code that I've written, but avoid any library functions like math.pow. So I keep clicking, and the blue bar shows the line that's going to be executed next. This line hasn't been executed yet, but as soon as we click again, it'll execute that line, which says pass control to the recpow function with the argument 2 and I. So as soon as I clicked step into, I see recpow show up in our stack list. And up here, I can see the values of base and exponent. Base is 2, exponent is 10. The way this function is supposed to work is it should loop 10 times, multiplying by 2 each time. I'm going to click step into a few more times, and I can see in my stack frame, I've opened another recursive pow function, which is normal. It should do that 10 times. But then I look up here and I notice every time that I'm opening a new recursive power function, my exponent is remaining the same. The escape case that I'm looking for is exponent equals 0, but if exponent is always 10 every time we come into the function, we're never going to get to that point. And then our program will crash when we run out of stack space. I'll just do this a couple more times so you can see that exponent is never decrementing. Of course, the problem is here. When I make the recursive call to recpow, I should be decrementing exponent by 1. So I'm going to fix that. And then I'll rerun my program. This little loopy play button will stop execution and restart it. Again, running right up to the breakpoint. So I click step into. Base is 2, exponent is 10. But the next time I step into, I see exponent is 9. I can keep clicking, or if I get bored, I can click on resume. The program will run again right up to the breakpoint. If we click over to the console, we can see that we've executed all these lines for I equals 10. We calculated 2 to the power of 10 twice, and also 10 factorial. If I click resume again, it runs again up to the breakpoint. So I'm pretty confident that this is working well. Let's stop execution here. I'm going to clear the breakpoint and run the program again. Well, I got through most of my program, but I see that I ended up with a problem when I equals 0. That happens a lot. 0 is considered an edge case. And we often see problems crop up when a variable equals 0. So we'll look again at the last line here, and it says my problem is actually in my recursive factorial function. Let's set our breakpoint again. I could set my breakpoint down here, but I want to show you something else. We'll enter the debugger. It starts execution, stops at our breakpoint. I'm going to push the step into button, but I know I don't have any problem with the power function, and I don't want to run through this a whole bunch of times. I can actually step over the power function. That means it's going to just go ahead and run this whole recursive function and pass execution down to the next line. We'll step over this. Now I is 9, comes back through. We know the problem came up when I equals 0, so we could just keep stepping through until I equals 0. Or we could force I to be 0. And the way we do that is to come over to our console and click this button that brings up a Python prompt. I'm going to set I equals 0, and we see that the value changes to 0 up here. Now I'm going to step over our two power functions and step into our factorial function. I see that the parameter num is set to 0, which it should be. And we'll keep stepping. And our parameter is -1. So what's happened is we've totally skipped over the escape case of number equals 1. 0 factorial should actually return 1. So maybe our escape case, instead of being num equals 1, should be num equals 0. So let's rerun the program and see if we get a better result. We'll go ahead again back to the console, set I equals 0, step over our power functions into the factorial function, and this time we got a result of 1. So let's stop the program, clear our breakpoint, and run the program again. Now the program runs without error, and we check the end. 2 factorial equals 2, 1 factorial equals 1, and 0 factorial equals 1. Those are the answers that we wanted to get. So our code is running fine now, but I just want to show you a couple more things. Let's set the breakpoint again, get into the debugger. One of the additional features we have is a watch list. We can click the plus button and add a variable like num that we'd like to watch. Now notice that there's no variable num within this scope. Num shows up in our recursive factorial function. So right now we get a name error. But let's try this. We're going to step over, step over, step over, step into. And when num is in scope, we see the value of num displayed over here. Of course, it's also displayed in our in-scope variables list over here. But for a complex program, you might have hundreds of variables in this window, and you might want to focus on 1 or 2 over in the watch window. So as we step through this function, we can see that num is decrementing. Let's click run again. I also want to show you the step out function. If we step into a function that we really didn't want to step into, it can take a lot of time to get out, especially a recursive function like this that's going to run 9 times. Instead of clicking step into a bunch of times, we'll actually click step out, and that function completes until control returns to the previous item in the stack. One other feature that I'd like to show you is called a conditional breakpoint. If we come to this breakpoint and right-click, we see we have a condition box. If we type in, for instance, I equals 5 as a condition, notice right now I equals 9. We have a little question mark showing up next to the red circle, which means this is a conditional breakpoint. If I click resume, then the code resumes until I equals 5. So if you know you're having a problem, say, at 0, we can set this conditional breakpoint to I equals 1, and then we don't have to step over and over and over again. We get all the way down to 1, and then we can step through. And that's all I have for you on debugging. I hope this helps make your programming experience a little more enjoyable, and I look forward to seeing you again soon.